We were concerned that, hey, like there's a wraparound and it was gonna have like
a significant drop. We only have really narrow concrete, exposed aggregate concrete driveways. As you can tell over here, this is really bad soil right here.
All this water is going to slope inside the building. Welcome back. This is Bill from WolfSteel Buildings. And in this video, what we're gonna be doing is we're gonna be explaining what the site prep experience is like. Usually, you know, when you are looking at a metal building, you reach out to us, you design your building, and then from there, we also, you know, give you a quote on a concrete as well. That concrete work is on a perfectly leveled site, okay? But we know that no ground is perfectly level, so therefore, you know, we have to do a site visit. In this project here, we are doing a site visit we're going to be building a 30 by 36 greenhouse and then a barn dominium shell as well. So I believe it's like a 40 by 60. I'll get the measurements. Marketing help us out with the preliminary design. But here, what we're doing is we're going to be looking at the elevations. How much dirt are we going to bring? How do we bring in the concrete? Right now, you can see that Willie behind is already staking out where our client wants her building right now, or their building. And so that way we can run some elevations. But there's a lot of things that we're going to be talking about here to give you guys a little bit more of an understanding. Okay, so hope you guys like this. Don't forget to like, share, and subscribe. And let's get this one going. Hey, Willie, I know right now you're staking out here. This is for the greenhouse, right? And then over there is going to be like what size is the barn dominium?
40 by 80.
40 by 80.
Yeah.
So that's on the other side, right?
Right.
Before we get into like the elevations, all that, the very first thing when we arrived was like, hey, how do we get the concrete trucks out here?
Yeah, we only have really narrow concrete, exposed aggregate concrete driveway. So keep in mind that it is considered decorative concrete, exposed aggregate. So any damages is going to be more costly, and then it's harder to match new exposed aggregate rather than new regular typical gray finished concrete, just the color gray.
That makes sense.
Yeah, it's probably over 1,000 feet of driveway. So, and then with a lot of curves, it's actually a really tough scenario for concrete delivery because I don't think it'll be convenient, or I don't recommend, in my opinion, to use that much line for pump.
So right now, that's what we're maybe considering to do 6-yard concrete trucks.
Right, yeah, to reduce the weight on them, to reduce any damage, risk of damage. So we'll bring them in 6 yards instead of the 10 yard.
Now those definitely do get a little bit more costlier because basically the labor of the truck and getting over here is basically the same. So it's like it's going to be a little bit more per yard for those, right?
Yeah, they'll charge more because they'll have to have more trucks available for us and more truck drivers. And then since they do get charged from anywhere from 7 yards and under, they charge a trip fee.
Yeah, that trip fee, right?
Mm-hmm.
That's something we're dealing with. So whether that we're still going to need a pump regardless, because we can't drive around and get that truck, the concrete on all 4 corners. So for sure, we're still going to need a pump.
Yeah, it's highly recommended, even though you have full access all around your slab. But if it's over 50 foot in one side, then it's highly recommended.
Highly recommended. And that usually runs from like 1,300 to like 3,000, just depending definitely the size and the length.
And also, since this one's gonna be 2 pours, it might be also time, because time they charge after 4 hours.
Yeah.
Of time, since this is going to be 2 pours, you know, they might have to set up over there and then move and set up over here, so it might be a little bit more time consuming.
Okay, you're going to be seeing some of the B-rolls. It's got low trees. They got low
hanging
trees.
So those do get damaged by the concrete trucks because
their height
their height is.
So we got the access, which is one thing that we're always checking. And now the location right here is where they're wanting. So you can see how it's like dropping down here, just a huge slope. So we definitely need like a stem wall or like a retaining wall
right
here, or else all this water is going to slope inside the building.
And we're actually going to have the stem wall a little bit higher than the existing floor right now, right here, even though we'll cut it out.
Okay.
Just to prevent, just like regular, like the 6 inches up. Of course, this side's gonna be taller though, because it keeps going downhill over here.
And then what made it really hard to, because it's a 30 by 36, for us to even try to square this, because we got a lot of bushes that we are going to be removing. So right now, you're probably seeing in B-roll, we stuck a tape measure straight. I think it was like 19 feet.
19 feet of brush.
Yeah.
Yeah.
Okay. And we're gonna leave it about 5 foot away from the fence.
So we have to be at least 5 foot away from the fence. Right now, the way they had it set up is all the way up to the fence. And we can't do that because we can risk getting into property lines, you know, in trouble with the city. Or if it keeps going downhill.
Is there a easement? Is there like a setback requirement? Five?
Okay. So I made sure to push it at least 5 foot.
This one,
like a couple inches extra. Yeah. To have room to play with.
But once we remove the bushes, if we can push it back in.
Yeah.
So site prep is really just to get a really good rough idea and good estimate. But then if there's possibility, we could possibly still move it right after we clear it up and then we get a full to be able to square it and everything.
Yeah, because right now you're not going to be able to square it because of all the brush.
Yeah. The other thing is, like, from a metal building perspective, that's more of me, right? I need at least 3-4 feet to be able to, you know, work around it and install the panels.
Right. So this is about halfway only.
Yeah.
You'll see the difference. We are at, we can just do it with this too. Let's see, we're at 4.2. 4.2.
To find where you are, which you set it at.
Yeah, exactly 4.2.
4.2.
Mm-hmm.
Okay. We're at like 7. Right there, 7. And there you go. 7.6.
7.6?
Yep.
Yeah, that's like almost 4 foot off level. So it's 3.5 off level to the half mark level, half of the building.
Damn.
So we still, if that's the
go dropping,
so it might drop another.
Well, you can see it's a little bit elevated here.
It might drop another foot, or a little bit over a foot, 1.6.
Okay.
But that's our level right there for this side.
Okay.
Now that side's gonna be even lower. Don't make my mistake and put your level up on the highest ground in here. 7 foot is the top part.
Oh, okay.
So yeah, about 7 foot.
7 foot. Okay.
Yeah, 7 foot. So that's 2 foot 10 inches off level on this side. I guess that one's lower there. It's about the same level. Oh yeah. Yeah, exactly the same.
It's exactly the same. Up here.
Yeah. So we're 2 foot 10 inches off level there. We're gonna be at least 5 foot off level on that side.
Yeah. But we're gonna cut into the ground, build a stem wall.
But we're also gonna lift this lower part a little bit. Maybe
that's what we're gonna determine right now. You know, hey, okay, we're gonna lift this part a little bit more, and that will allow us to calculate everything. But just having this, we can do this all at the office.
Yep.
It's especially like these type of site visits where there's a lot of elevation differences, and it's hot out here sometimes, or it's been a long day. Sometimes those numbers, it's better to just sit down and calculate them in the office. Unless it's like really nice level, because you're gonna see on the other side, it's already pretty level for the other building. Then that can be done, like sometimes you can even do it from the truck.
From the actual site.
Yeah, but this one, we gotta do a little bit of planning, especially for this specific one.
Anytime there's a stem wall or a retaining wall, And the difference between both of those is a retaining wall is always separate from the slab, and a stem wall is with the slab itself. So it's the footer that's raised up.
Alrighty, so now we're at the site of where what size is it? Like a 40 by 90?
40 by 80.
40 by 80.
But with the lean-to, it's
gonna have a wrap
by 90.
It's gonna have a wrap around, right?
Yeah, right.
Is it gonna be like in the front here on this side?
Yeah, on the left front and left side.
Okay.
I mean, right.
And one thing that we liked about our client here is that they already have it kind of just marked, just some rough, little flags to show their goal of where they want to start. So before your site visit, it would be great to, kind of mark where you're wanting it, because a lot of times our concrete foreman is just going to arrive. A lot of times they're not fully knowledgeable in the building. They're more knowledgeable about the site. As long as you mark it, they're going to come here and they're going to shoot elevations, and it's going to be pretty straight where it makes it a lot easier for everyone. So if you just kind of give it a marking, give an idea, and also suggest any other ideas, because we're going to suggest some other ideas like, hey, if we shift it, which we did for the greenhouse, we did tell our client, hey, if you shift it a little bit, it could save you a little bit more money, and it would be a better layout, easier, where there's not a lot of costs involved. At the end of the day, we're the experts. We're supposed to give you guys options, right? But if you kind of leave like some flags, it gives us the idea where you're wanting it, and it helps us get us, started. Yeah, so that one's going to be a retaining wall. So you can see on there, mark and show here, they do want a retaining wall, which honestly, look, it would look better.
Yeah.
Have that retaining wall.
Because now we don't have to worry about all the fill material washing off. You're going to be held with the retaining wall. So this building for sure is highly recommended to have those piers because of this drop.
Yeah. Since this is going to be a barn-dominium or like a living space, it's going to have to get engineered, right? So all our projects, when it involves like commercial or residential, that's just a WolfSteel policy. We get everything engineered. That's just how it is. I know out there's a lot of non-engineered, but especially for foundations, this can be deceiving. It looks pretty solid, but we don't know what's under. There's a lot of clay under here, especially here in Dallas-Fort Worth.
Yeah, as you can tell over here, this is really bad soil right here. It's probably what's underground.
Yeah, you can see
all that.
Yeah, that's all bad soil. You can see all the cracks.
Really good for planting, but not for building.
This type of soil expands and contracts as it rains and it dries, and therefore it moves a lot. So there's a lot of movement, right? So at the end of the day, your ground, we don't know what's under. So if we get a geotech, which is a soil test, they'll drill into the ground, they'll take out our borings, they'll take it to the lab. And that's where those experts will determine, hey, this is how you should design the slab to make sure it's a long-lasting foundation. So that's why we require all our foundations and our metal building to be engineered if it's residential or commercial. Why is the highest point really important?
Like in order to prevent water seepage or to flow out any type of water.
Yeah.
You got to get your highest elevation and go from there. Because if you go, anything lower than this side, you're going to have to dig out. And now it's going to be like lower than everything around it.
Like down.
And water can...
Like right here, you can tell like the water goes like right there.
Yeah.
That's why you see like a little right there, like a little, like it's still wet. The water holes right there.
Yeah. So if you get your highest point and you go based off of that, you're going to be safe.
You're going
to be safe with any...
We set it above 4 inches above grade.
4 to 6 inches.
4 to 6 inches.
Minimum of 4.
Yeah.
Minimum 4.
Also depending the thickness, right, of the slab.
Right. Okay, we are at 11 inches.
11 inches. This is one of the corners, the back corner.
Two foot 5.
2'5".
So we're 1 foot 4 inches.
If we weren't doing piers,
yeah,
right, because we're gonna definitely bring in fill to level, right, grade it out. But if we didn't bring piers, what we would have had to do is go into undisturbed soil. So we would go how much off level here was 2 foot something?
1 foot 4 inches off level.
1 foot 4 inches, right?
Mm-hmm.
And then if the engineer requires 12-inch minimum footings into undisturbed ground, what that means is 1 foot 4 plus a foot, so it means 2 foot 4 inches.
Yeah,
on footer.
The plus whatever you have of form.
Oh, okay.
So 18 inches.
18 inches.
Yeah, plus your 1 foot 4 inches off level. Because this level that I'm shooting right now, this is going to be your top of grade of dirt.
That makes sense. So the footings have to go into not only because all this fill is, as much as we compact it, it's not going to be compacted like right now how this exists in
like the original soil.
The original soil. So when the concrete gets poured, it's going to settle. And so what we want to do is we want to get those footers to go past all the alien soil into 12 to 18 inches minimum into the natural grade. That way is the foundation is sitting on solid ground. That's one thing that we've noticed, that when we get compared bids with other bids, it's like we actually go into undisturbed soil, which is a lot more solid foundation. So it's just something to really look out, because that's been something that we've been seeing, that it's a little footnote in the plans, just a little line that says into undisturbed soil. And it makes sense why, because then you tend to have like cracks in your foundation, because like once it settles, then you got like, because it's just basically flying in the air, sitting on select fill that was just brought in, especially for residential projects. If it's like commercial, where you can get some of the bigger equipment and you can compact the ground in a certain way with water and like different process, then that's a different process. But most cases can't really get that type of equipment and do the compaction tests in a cost-effective way and in a simple way to do it. So for residential, that's why we do a lot of our projects. We just go into undisturbed soil.
Hey, Adriel, you ready to go down there and get that level?
Yeah, let's do that.
So I think I'm 6 foot tall, so maybe 9. We're 2 foot 1.
Yeah, you're 2'1".
And how much is it between this and here? About a foot.
Yeah, about 8 to 10 inches. 10 inches.
Yeah, so 9 foot off, about 9 foot off level out here.
What? Would it be an option to suggest to our client push it forward, to push it more this way?
I don't think so, because this corner is really pushing it right here to this existing house.
Yeah.
So I think that's what they're trying to avoid. But they are getting the retaining wall, and that's really going to help out.
Okay.
I guess the cost of the material with something that off level is what really makes a difference.
Yeah.
I didn't expect it to be that much.
Yeah, I didn't expect it to be that high either. Well, obviously, because that was just 9 up there, right?
Yeah.
You have to subtract the height of your bottom note?
No, that's level up there to the floor. But to this, to that.
Or to that?
To the highest point. That's the same level, 9 foot. So then you have to raise it up the 6 inches.
Well, there you have it.
Since it's going to be a stem wall holding all that, pressure, retaining wall, we're going to have a design to go from roughly, I'd say 18 inches all the way down, expanding, getting wider at the bottom.
Yeah.
Because that'll,
like a bell.
Yeah, like a bell. That'll hold a lot more pressure from the dirt. But the piers will help the retaining wall as well.
Yeah.
Yeah, because if the ground moves a little bit or whatever,
this springs or
the piers are actually going to help everything. Everything works as a team.
You can tell some trees were removed. So if you're removing trees, typically engineers require to have piers, because all the roots that are still in the ground, they're eventually gonna decay.
Yeah,
therefore there's gonna be settling happening.
Yeah, because they're gonna create like pockets or hollows
in the ground. Alrighty, Willie. So we actually just talked to our client. We got a lot of answers, right? So obviously the retaining wall, we were concerned that, hey, like there's a wraparound and it was gonna have like
a significant drop.
But the retaining wall is also going 5 foot out.
Yeah, that wrap around.
The other concern, remember we were talking about earlier, was like, how do we get concrete here? Because their driveway is like really narrow, and we could definitely damage that driveway.
Right. Probably over 1,000 feet of driveway. So, and then with a lot of curves, it's actually a really tough scenario for concrete delivery, because I don't think it'll be convenient, or I don't recommend, in my opinion, to use that much line for pump.
And we were looking, hey, like there's some roads on the outside.
Yeah.
What did we find out?
So we asked the client if, what that road is on the other side of the fence of the property line. And she actually came out here and pointed out that there's an actual like construction access road you know, for heavy equipment, heavy trucks, you know, so just our luck right there.
Yeah.
Super easy to access to this road. Now we don't have to worry about, you know, doing anything damaging to their driveway or the trees or whatever. We can have full access all the way up to the site.
We still might need a pump though, because we can't really get to the other building. Or if we decide to do it on a single pour, which honestly I think we possibly could the same day.
Yeah, we could the same day. And
Yeah.
we would definitely still need a pump because, like I said earlier, this building is definitely is really about in concrete language. It's 90 foot.
Yeah.
Because we go based off the full length, including lean-tos, including patios and everything, you know, most outer space. So it's 90 foot long. So definitely don't recommend tailgating that.
Yeah.
You know, you definitely want to pump it, especially in the summertime.
There you have it, guys. That's what a site visit is. Again, the biggest number one problem we're trying to solve is how do we get concrete here? 1, 2 is, you know, elevations and making sure where's water going, and definitely obviously the cost for doing all the work, of course, and also understanding, you know, what type of project it is. So if it's just a garage workshop, okay, a little bit more simpler process. But if it's something like a living, then definitely has to go with engineering. So we got to also account for that. Still got to wait a little bit for a geotech as well.
Yeah, for sure. We will need it here in this project.
I know it was a little bit more on the boring side, but it is also really important. It's probably the most important phase of a project is the planning. So,
right.
All right. We always say we construct on paper, and then we just come in and just execute on site. So we'll see you guys in the next video.